Alright, so now we're going to continue. We're on page 13. We're going to create now a modified box plot. Modified box plots have a little bit more detail to them, and they actually detect for the presence of outliers with an algorithm that we're going to lay out right here on this page. So what we need to do is find what are called fences, beyond which data values that fall beyond these boundary fences are going to be considered unusual, and therefore they're going to be outliers. So what we have to start with is the interquartile range. If you remember the interquartile range, IQR is the abbreviation for that. It's simply quartile 3 minus quartile 1. And then if we look back at our data for the boys, quartile 3 was 23. Quartile 1 was 18, so the interquartile range for the boys is 5. That gives us an idea of how widely dispersed, we could say, the middle 50% of the data is. In order to calculate the fence, we're going to take this interquartile range of 5 and we're going to multiply it by 1.5. And that'll give us a boundary that's going to serve as this fence. So we'll just take this 5 times 1.5, and that equals 7.5. And we're actually going to add and subtract 7.5 onto either side of the interquartile range, or in either side of quartile 1 and quartile 3 points, to figure out where these imaginary boundaries are. So, we'll call it the upper fence. For the upper fence, on the top part of your graph, you're going to take quartile 3, and you're going to add 7.5. It's not always going to be 7.5, but for this case it is 7.5. You would calculate this based on your actual problem. So quartile 3 is 23 plus 7.5. The upper fence is 30.5. Lower fence, since we're working in the lower direction now, we want to subtract this from Q1. We're going on the left-hand side. So we're going to take the lower quartile, subtract 7.5 to find out what our low boundary is going to be. So we got 18 minus 7.5, which is 10.5. So this is our lower boundary, lower fence, upper boundary, upper fence. Now, these are just fences, and think of them as imaginary boundaries just to establish a cutoff point for outliers, a cutoff point for identifying unusual values. They are not included as points in the data set, so on the box plot you don't even want to show them as if they were points on the data set. Some software packages, or some people even suggest that you just sketch them in as perhaps like dotted lines or dashed lines, and maybe that's what we'll do. Let's go ahead and do this same math for the girls. So for the girls, the interquartile range, quartile 3 minus quartile 1 is 25 for quartile 3 minus 20 for quartile 1. So the interquartile range for the girls is 5. It's a coincidence that it's the same as the boys. It won't necessarily be that on other problems. Multiply that by 1.5. 5 times 1.5 is, shockingly, 7.5 again. Now let's figure out where the girls' fences are. Those will be in a different place. So let's do the upper fence. And the upper fence, if you recall, is quartile 3 plus the 7.5. Quartile 3 was 25 plus 7.5 is 32.5. Lower fence, quartile 1 minus 7.5. Quartile 1 was 20 minus 7.5 is 12.5. So these are the boundaries we're going to use for the girls to determine if there are any unusual values or any outliers. So if an outlier does exist, so if we have data values beyond these fences, boys or girls, what you're going to do is you're going to draw the whisker only out to the largest value or the smallest on the low side. We're going to use the value just inside the fence, and we're going to stop there. So I'm going to show the page from before. On here we went all the way out to the maximum numbers here to the minimum numbers here. Now what we're going to do is figure out in the fence if there's any of these that we're going to count as outliers. So if we do find an outlier, what we're going to do is show that with a small filled circle instead of the whisker going all the way out to the data value. As a further note, the data value, an outlier is considered very extreme if it lies beyond 3 times the interquartile range on the plus or minus side. These will be drawn as open circles instead of small filled circles. So a regular outlier will show this way. An extreme outlier would be just shown that way. And not all software is going to show it as a solid dot and an open dot. It could be like an asterisk or just a different symbol than the other ones. Alright, so let's figure out first if we have any outliers. So let's look at the boys data. The upper fence is 30.5, so the upper fence actually would fall outside of this data value. The lower fence is 10.5, which would fall way outside. So the boys data is centered enough, is tight enough, no outliers. Let's check the girls. The girls data, the upper fence is 32.5. So there's nothing above that. The lower fence is 12.5. So I'm going to come here and I'm going to just put a little dotted line right there, 12.5. So we do have one value that is an outlier on the low side for the girls. Okay, so the instructions told us that we need to stop our whisker at 16 now instead of 12. So it's going to look a little different than that. Instead of coming all the way up to 12, it's going to stop at 16. So let's go ahead and show the girls' graph here. And the boys' graph doesn't change at all. So I'm actually not going to redraw that one. We can just compare it to the original. So the rest of the graph stays the same. So the median's at 23. Quartile 3 is at 25. Quartile 1 was at 20. Draw your center rectangular box representing the middle 50%. There was no upper outlier, so we're going all the way to 28 on the upper end. And on the lower end, what do we say? We do have one outlier. The value closest to that without being in the outlier range is 16. So now we're going to put our vertical bar at 16, draw the whisker, and then whatever points are below the fence will be drawn as a dot. In this case, only the 12. So we will draw that as a solid dot. And there's your modified box plot. So basically it draws your attention, more to the bulk of the data. You would need to investigate this outlier, but it may not be important. I don't know, maybe that girl was sick that day. And now if you compare, the two graphs, I forget where the boy was, there it goes. If you compare these two graphs, they are much more similar without that outlier for the girls. Alright, I'm going to stop there before we go on to the next page, which will be doing this on your calculator.